Hello everyone, I'm Ms. Kanau, one of your grade 11 maths teachers. In our previous lesson, we looked at logarithm table, which was the last lesson of the topics that we have learned in Term 1. In today's lesson, we would be recapping on what we have already learned. There are three main important topics that we looked at in Term 1, and the first one is on surds. Surds is an irrational number. We also looked at irrational number during the term. I'd give you an example of how we can rationalize the denominators of surds. Example number 1, it would give us 6 over a denominator of 5 root 3. We will simplify and apply the properties of surds rule. That would give us to 6 over 5 root 3, and we multiply that by root 3 over a denominator of root 3. Now, we will need to simplify. How do we do that? We will simplify by multiplying the numerator by the numerator, which gives us 6 root 3, and the denominator by the denominator. 3 root 3 multiply root 3 gives you to root 9, and we have 5 root 9. With 5 root 9, we know that we can find the square root of 9, which is square root of 9 equals 3. Let's simplify further by writing 6 root 3 over a denominator of 5 times 3. We can simplify, and to simplify, we have 3 and 6. 3 is a factor of 6. 3 into 3 goes 1, and 3 into 6 goes 2. The simplified version gives us the 2 root 3 over a denominator of 5. Looking at that, we need to simplify further. So in order for us to simplify further, we would have 2 multiply, and root 3 is equal to, if I have to calculate the value of that, would give me to 1.7320 to 4 decimal places, all of that over a denominator of 5. When multiplying these out, it would give me to the product of 2 and 1.7320 would give me to 1.464 decimal point and 3. Again, I need to divide it by 5. And if I were to divide it by 5, dividing 3.4641 divided by 5, it would give me to a value of 0.6928. The value of 6 over a denominator of 5 root 3 is 0.6928 8, and it continues on infinitely. That is only an example on surds. There are more examples where you can use to help to solve the topics on surds. Now, let's look at the second topic. And in the second topic, we looked at exponent. We have covered indices or index law. This is exponent, and we used that, or we studied about that and examples in our lesson in Term 1. This is only one of the examples. There's many more you can go through. And that gives us 8x to the power of 4 subtracting 3 is equal to 2. The first step that we need to do is to get rid of the minus 3. And the opposite of that is a plus 3. You need to do it to both sides. And it gives you to 8x to the power of 4 is equal to 2 plus 3 equals 5. So you have 5 here. The second step, you need to get rid of the coefficient 8. And that would give you to, you divide by 8. Why do you divide by 8? It is the opposite of 8 multiply x. So that would give you to divide by 8, x to the power of 4 is equal to, dividing to both sides, 5 over a denominator of 8. You still have something left, and that is the number 4, which is the power or the exponent. What do? You will have to get rid of that by simplifying. In order to simplify, we find the reciprocal of 4. In fractions, when you talk about reciprocal, you talk about changing the fraction upside down. If it is 2/3 or 2 over denominator 3, the reciprocal of 2 over 3 is 3 over 2. With that, we now have the reciprocal of that, which is you must multiply by 1/4. So you multiply x to the power of 4 by 1/4, you're left with x. You do the same. So that gives you to 5 over a denominator of 8, all of that raised to the power of 4. And x is equal to 5/8 to the power of 4 will give us to x. Therefore, x is equal to 0.8891. That concludes an example on exponent. There are plenty more examples that you can find to apply the properties and the skills that we have taught in this term. The last topic that I'd like to recap is on logarithm. Logarithm. And what is logarithm? We won't go into big expressions. So if we have log base b x is equal to y, we know that b is the base, y is the exponent, and x is the result. So we can now say if it is in the form of an exponent, it would be base b to the power of y, and its value or result would be x. And that is the basic of what we would be looking at today. So if I have an expression, and the expression is the first expression, it gives me 2 is equal to log base 7 x. Then all I need to do is to solve it by expressing into a form of an exponent. If 2 is equal to log base 7x, then it would imply the base is 7, the power is 2, or the exponent is 2. All of that is equal to x. Note, we are not trying to calculate or find the value of x. All we're trying to do is to see the relationship between a log expression to an exponent expression. Now, the second example would give us 3 is equal to log base 10 x plus 8. Note that x plus 8 is bounded by a parenthesis or grouping symbol. That means that x and 8 is one number when we calculate the value of x. But we're not interested in calculating the value of x. We want to see how, or the relationship between a basic log into an exponent. So that would give us 2. The base 10 raised to the power of 3 is equal to brackets x adding 8. Our final example now on logarithm would give us 2 log base 5, 125, all of that is equal to x. That simply means when trying to understand its relationship as an exponent or exponential function or expression, it gives us the base 5, all of that raised to the power of x, and its result is 125. That brings us to the end of the examples on logarithm, and the 3 examples that covers or recap what we have covered in Term 1. And in your next term, you would be looking at geometry. And when you look at geometry, it's to do with shapes and length and heights. And you would be using some of the topics that we have covered in Term 1 to solve geometrical problems. I hope you have learned some things in Term 1 and you've enjoyed this lesson. Thank you very much. Bye-bye.